When sizing a subpanel, you must use the same calculations and procedures as you would for sizing the main service panel. This ensures the subpanel can safely handle the electrical load connected to it. After calculating the load on the entire house, recalculate the load specifically for the subpanel. This involves several steps. Firstly, identify all devices and appliances that will be connected to the subpanel. Secondly, calculate the amperage draw of each device. Use the manufacturer's specifications or appropriate electrical code tables for this. Thirdly, sum all the individual amperage values to determine the total load in the subpanel. To verify your calculations, consider these points. The total load in the subpanel must be within the capacity of the subpanel breaker or fuse. The number of branch circuits needed depends on the amperage draw of all the devices connected to the subpanel. The neutral current should be balanced across all the branch circuits in the subpanel. The subpanel must include ground fault protection, either through ground fault circuit interrupters, also known as GFCIs, or an equipment grounding conductor, also known as EGC. Now let's look at an example calculation. Suppose the main service panel has a total load of 12,000 watts and a service amperage of 100 amps. For the subpanel, imagine the following devices are connected: an electric range drawing 40 amps, a refrigerator drawing 15 amps, and lighting circuits drawing 20 amps. The total load on this subpanel would be 75 amps. In this case, an 80 amp subpanel breaker would be appropriate because it exceeds the 75 amp calculated load. Let's delve deeper into the process of calculating electrical loads for both the main service panel and subpanels. Accurate load calculation is paramount to ensure electrical safety and prevent overloading, which can lead to overheating, damage to equipment, and even fire hazards. For the main service panel, the first step involves determining the total connected load of all electrical devices and appliances within the house. This includes lighting, heating, air conditioning, cooking appliances, water heaters, and any other electrical equipment. Each device's power consumption is typically indicated in watts or kilowatts on its nameplate or in the manufacturer's specifications. To convert watts to amps, use the formula amps equals watts divided by volts. In residential applications, the standard voltage is typically 120 volts for lighting and small appliances and 240 volts for larger appliances like electric ranges and dryers. After determining the connected load, apply demand factors as permitted by the National Electrical Code, known as NEC. Demand factors account for the fact that not all electrical devices will be operating simultaneously at their maximum power consumption. For example, the NEC allows for a demand factor of less than 100% for certain types of loads, such as electric ranges and heating equipment, based on the assumption that they will not all be used at the same time. Applying demand factors can significantly reduce the calculated load on the main service panel, resulting in a smaller service size requirement. Once the total demand load for the main service panel has been calculated, select an appropriately sized service entrance conductor and overcurrent protection device such as a circuit breaker or fuse. The size of the service entrance conductor must be sufficient to carry the calculated load, and the overcurrent protection device must be sized to protect the conductor from overloads and short circuits. Now, let's shift our focus to sizing subpanels. The process for sizing a subpanel is similar to that for sizing the main service panel, but it's essential to consider only the loads that will be served by the subpanel. Begin by identifying all the electrical devices and appliances that will be connected to the subpanel. This may include lighting, receptacles, small appliances, and dedicated circuits for specific equipment. Determine the amperage draw of each device using the manufacturer's specifications or electrical code tables. For receptacles, assume a minimum load of 180 volt amps per receptacle outlet as required by the NEC. For lighting circuits, calculate the total wattage of all lighting fixtures and divide by the voltage to determine the amperage. After determining the connected load for each device, apply demand factors as permitted by the NEC. Demand factors may be applicable for certain types of loads served by the subpanel, such as lighting or receptacle circuits. Calculate the total demand load for the subpanel by summing the individual loads after applying any applicable demand factors. Select an appropriately sized subpanel breaker or fuse to protect the subpanel from overloads and short circuits. The size of the subpanel breaker must be sufficient to carry the calculated load, but it should not exceed the ampacity of the subpanel conductors. Ensure that the subpanel conductors are sized appropriately for the calculated load and the rating of the subpanel breaker. The NEC provides guidance on conductor ampacity based on conductor size, insulation type, and installation conditions. In addition to load calculations, consider other factors when sizing subpanels. These include voltage drop, conductor diarrheting, and future expansion. Voltage drop occurs when the voltage at the load end of a circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, select conductors with a larger cross-sectional area or shorten the length of the circuit. Conductor diarrheting may be necessary when conductors are installed in certain environments, such as in conduit or near heat sources. The NEC provides diarrheting factors to account for these conditions. Plan for future expansion by selecting a subpanel with sufficient capacity to accommodate additional circuits and loads. This will avoid the need to replace the subpanel in the future if additional electrical equipment is added. It's crucial to adhere to all applicable electrical codes and regulations when sizing subpanels. The NEC provides comprehensive guidance on electrical installations, including load calculations, conductor sizing, overcurrent protection, and grounding. Consult the NEC and local electrical codes to ensure compliance with all requirements. Consider obtaining a permit from the local building department before installing a subpanel. A permit ensures that the installation will be inspected by a qualified electrical inspector, who can verify that the work meets all applicable codes and regulations. In summary, accurate load calculation is essential for safely and effectively sizing both main service panels and subpanels. By following the steps outlined above and adhering to all applicable electrical codes and regulations, you can ensure that your electrical system is properly sized and protected. Let's go over some more specific aspects of subpanel sizing, including neutral sizing, grounding requirements, and ground fault protection. Proper sizing of the neutral conductor is crucial for ensuring safe and reliable operation of the electrical system. The neutral conductor carries the unbalanced current from the load back to the source. In a balanced 3-wire circuit, the neutral current is 0. However, in an unbalanced circuit, the neutral conductor carries the difference between the currents on the hot conductors. The NEC provides guidance on sizing the neutral conductor based on the type of load served by the circuit. For circuits serving primarily nonlinear loads such as electronic equipment and fluorescent lighting, the neutral conductor may need to be oversized to account for harmonic currents. Harmonic currents are produced by nonlinear loads and can cause overheating of the neutral conductor. The NEC requires the neutral conductor to be sized at least equal to the maximum unbalanced load. In some cases, the neutral conductor may need to be larger than the hot conductors to accommodate harmonic currents. Grounding is another essential aspect of subpanel installations. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to protect people and equipment from electrical shock hazards. The NEC requires all metal enclosures and equipment to be grounded. This includes the subpanel enclosure, metal conduit, and metal boxes. Grounding is typically accomplished by connecting the metal enclosure to the equipment grounding conductor, also known as EGC. The EGC is a dedicated conductor that runs from the subpanel back to the main service panel and is connected to the grounding electrode system. The grounding electrode system consists of one or more grounding electrodes, such as ground rods or metal water pipes, that are connected to the earth. The NEC provides guidance on selecting and installing grounding electrodes. Ground fault protection is another critical safety feature for subpanels. Ground fault protection is designed to detect and interrupt ground faults, which occur when current flows from a hot conductor to ground. Ground faults can be caused by damaged insulation, loose connections, or other faults in the electrical system. Ground fault circuit interrupters, known as GFCIs, are commonly used to provide ground fault protection for receptacle outlets in bathrooms, kitchens, and other wet locations. GFCIs are designed to trip when they detect a ground fault current of 5 milliamps or more. Equipment grounding conductors, known as EGC, can also provide ground fault protection. EGC are designed to carry fault current back to the source, which causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and interrupt the circuit. The NEC requires ground fault protection for certain types of equipment, such as electric ranges, dryers, and water heaters. Now, let's discuss some common mistakes to avoid when sizing subpanels. One common mistake is underestimating the load in the subpanel. It's essential to carefully consider all the electrical devices and appliances that will be connected to the subpanel and to accurately calculate their amperage draw. Another common mistake is failing to apply demand factors as permitted by the NEC. Demand factors can significantly reduce the calculated load on the subpanel, resulting in a smaller subpanel size requirement. However, it's important to apply demand factors correctly and to ensure that they are appropriate for the type of load served by the subpanel. Another mistake is oversizing the subpanel breaker. While it may seem like a good idea to install a larger breaker to provide extra capacity, this can actually be dangerous. An oversized breaker will not provide adequate protection for the subpanel conductors, which can lead to overheating and fire hazards. The subpanel breaker must be sized appropriately for the calculated load and the opacity of the subpanel conductors. Another mistake is neglecting to properly ground the subpanel. Grounding is essential for electrical safety and helps to protect people and equipment from electrical shock hazards. Make sure to properly ground the subpanel enclosure, metal conduit, and metal boxes. Another mistake is failing to provide ground fault protection where required by the NEC. Ground fault protection is designed to detect and interrupt ground faults, which can cause electrical shock hazards. Make sure to install GFCIs or EGC where required by the NEC. Another mistake is not considering future expansion when sizing the subpanel. It's a good idea to select a subpanel with sufficient capacity to accommodate additional circuits and loads in the future. This will avoid the need to replace the subpanel if additional electrical equipment is added. In conclusion, sizing subpanels correctly is crucial for ensuring electrical safety and preventing overloading. Remember to use the same calculations and procedures as you would for sizing the main service panel. Accurately calculate the load on the subpanel, apply demand factors as permitted by the NEC, and select an appropriately sized subpanel breaker and conductors. Also, be sure to properly ground the subpanel and provide ground fault protection where required. By following these guidelines, you can ensure that your subpanel is safely and effectively sized for its intended use. Consider the specific requirements of your local electrical codes, as these may have additional requirements or variations compared to the NEC. Local codes can be more stringent to address unique environmental factors, specific building practices, or other regional considerations. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about sizing subpanels. They can provide expert guidance and ensure that your electrical system meets all applicable codes and regulations. Furthermore, remember that electrical work can be dangerous, and it's always best to leave it to the professionals. Working with electricity requires specialized knowledge, skills, and equipment. Attempting to perform electrical work without proper training can result in serious injury or even death. If you're not a qualified electrician, don't attempt to install or modify electrical wiring. Instead, hire a licensed electrician to do the work for you. Remember to turn off the power to the circuit before working on any electrical equipment. This will help to prevent electrical shock. Use appropriate safety gear such as rubber gloves and safety glasses when working with electricity. Inspect your electrical system regularly for any signs of damage or wear. Look for frayed wires, cracked insulation, and loose connections. If you notice any problems, contact a qualified electrician to make repairs. Keep electrical panels and outlets clear of obstructions. This will help to prevent accidental contact with live wires. Do not overload electrical circuits. Overloading can cause overheating and fire hazards. Use surge protectors to protect electronic equipment from power surges. Power surges can damage sensitive electronic components. Be careful when using electrical appliances near water. Water is a good conductor of electricity, and contact with water can increase the risk of electrical shock. Never use damaged electrical cords or appliances. Damaged cords and appliances can cause electrical shock and fire hazards. Store flammable materials away from electrical equipment. Flammable materials can easily ignite if they come into contact with a spark or hot surface. If you smell gas, evacuate the building immediately and call the gas company. Gas leaks can cause explosions and fires. If you see sparks or smoke coming from electrical equipment, turn off the power and call the fire department. Sparks and smoke are signs of an electrical problem that could lead to a fire. Educate yourself about electrical safety. The more you know about electricity, the safer you will be. Take a class or read a book about electrical safety. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force that must be treated with respect. Always follow safety precautions when working with electricity. It's always a good idea to label all circuits clearly in the subpanel. Use a permanent marker to write the circuit number and a brief description of what the circuit serves on the label. This will make it easier to identify the correct circuit when you need to turn off the power for maintenance or repairs. Keep a record of all electrical work that you have done. This record should include the date of the work, the name of the electrician who performed the work, and a description of the work that was done. This record will be helpful if you ever need to make repairs or modifications to your electrical system in the future. Inspect your electrical system at least once a year. This inspection should include checking for loose connections, damaged wires, and other signs of wear. If you notice any problems, contact a qualified electrician to make repairs. If you are planning to do any remodeling or construction work, be sure to contact a qualified electrician to discuss your electrical needs. The electrician can help you to determine the correct size and location for new circuits and outlets. Consider using energy-efficient lighting and appliances. Energy-efficient products can save you money on your electric bill and help to reduce your carbon footprint. Turn off lights and appliances when you are not using them. This will help to save energy and reduce your electric bill. Unplug electronic devices when you are not using them. Even when turned off, electronic devices can still draw power. Install dimmers on your lights. Dimmers allow you to adjust the brightness of your lights, which can save energy and create a more comfortable atmosphere. Use timers to control your lights and appliances. Timers can turn lights and appliances on and off automatically, which can save energy and improve security. Install motion sensors on your outdoor lights. Motion sensors will turn on your outdoor lights automatically when someone approaches, which can deter crime and improve safety. Insulate your home properly. Proper insulation can help to reduce your heating and cooling costs. Seal any cracks or gaps in your windows and doors. This will help to prevent drafts and save energy. Plant trees and shrubs around your home. Trees and shrubs can provide shade and reduce your cooling costs. Use a programmable thermostat. A programmable thermostat can automatically adjust your thermostat settings based on your schedule, which can save energy and money. Consider installing solar panels. Solar panels can generate electricity from the sun, which can reduce or eliminate your electric bill. By following these tips, you can save energy and money on your electric bill while also helping to protect the environment. Remember to consult with a qualified electrician or energy auditor for more information on how to save energy in your home. They can provide personalized recommendations based on your specific needs and circumstances. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force that must be treated with respect. With proper planning and execution, installing a subpanel can be a safe and effective way to expand your electrical capacity.